audible?
Yes, ma'am. You are audible, ma'am.
Yeah, Patange sir joined or not
Yes,
yet?
yes. Yes, ma'am. Patange sir has
Uh,
joined, ma'am.
welcome, sir. Patange sir, welcome. Patange sir, welcome, sir. Patange sir, please unmute yourself. Unmute yourself. Ankush? Ankush, are you? Ankush?
Yes, ma'am.
Have you joined?
Yes, ma'am.
Krishna sir?
Yes, ma'am. Yes, ma'am. We are here, ma'am.
Krishna sir.
Yes, ma'am.
Ask Patange sir to unmute himself.
Okay, ma'am.
How many participants joined?
Uh,
24.
24, ma'am.
Okay. Wait for a
We have.
5 minutes and start the
Yes.
session, sir, please.
Yes, ma'am.
Yeah,
We are
please.
waiting for the participants.
Yes. And what about Patange sir's PPT available now? Is it?
Yes. Everything is there, ma'am.
Okay, sir. Then proceed with the session.
Okay, ma'am. Within 5 minutes, I will
Thanks.
start the session.
Yes.
Anuja ma'am,
Yes.
good afternoon.
Good afternoon.
Good afternoon, madam. Good afternoon.
Good
Can
afternoon,
you?
Patange sir. Welcome.
Yes. Thank you.
Yes, sir. It's a very great to have you for today's session, sir. Welcome on the behalf of the English Department, Rajesh Shaw Mahavidyalaya Autonomous Latur.
Thank you, madam.
Krishna, sir, please proceed.
Yes. Good afternoon, one and all the participants and resource person of today's CBP session. I am Krishna Deshmukh on the behalf of Department of English, Rajarshi Shahu Mahavidyalaya Autonomous Latur. I welcome you all in this CBP session. Dear participants, we are honored to have Dr. H.S. Patange sir as a resource person of today's session. I am extremely happy to welcome you, sir, in today's session.
Thank you.
Now the session will begin with introduction of the today's resource person. Doctor, the full name of the resource person is Harishchandra Shesharao Patange, who has been working as Vice Principal, Professor and Head Department of Commerce, Yashvant Mahavidyalaya, Nanded. He has completed his MCom, MBA, MA in Economics, also qualified SET, NET, and received his PhD degree in Commerce from Swami Ramananda Tirth Marathwada University, Nanded. Sir has published 25 research papers and author of 2 books. Also, he contributed as a research supervisor for PhD students. Under his guidance, one candidate has submitted his PhD thesis recently, 7 candidates are working for PhD, and 9 candidates awarded PhD degree. Apart from his this, Sir is working for co-curricular and extension activities such as he worked as a coordinator for Unnat Bharat Abhiyan, program officer for NSS, coordinator for Students Commerce Association, coordinators of Students Management Association, coordinators of Students Banking Association, coordinators of Students Tax Association. He also working on various universities bodies such as first of all, I would like to congratulate Dr. Patange sir because he has newly elected member of Academic Council, Swami Ramananda Tirth Marathwada University, Nanded. Also, chairman of Board of Studies in Commercial and Mercantile Law, member of Academic Council, member of Research Recognition Committee, member of Board of Studies in Business Economics, member of Faculty of Commerce, member of Board of Studies in Accounting and Applied Statistics, member of Faculty of Commerce, member of Committee of Board of Examination and Evaluation. Also, he worked as a member of Board of Studies in Mercantile Law of Rajarshi Shahu Mahavidyalaya, Latur, as well as BOS in Accounting and Taxation of Rajarshi Shahu Mahavidyalaya, Latur. Sir has presented papers, as worked as a resource person, invited lectures in seminar, conferences, workshop, and symposia at national, international, regional, and state level also. He worked for the community services and organized 6 blood donation camps in 3 years. Also, he donated blood for 10 times as a motivator for students and coordinator of Unnat Bharat Abhiyan, a flagship program of Ministry of Education, Government of India. He also working on a various universities committees, uh, worked as an affiliation scrutiny committee as a member for 2 years, worked as a university subject expert or VC nominees for 6 times, worked as a university subject expert, worked as a university subject expert in Avishkar Research Festival 2019 Berlin. He is also a life member of Indian Commerce Association, a professional national organization. So, this is a short introduction of today's resource person, Dr. Patange sir. Now, I request Dr. Patange sir to talk on the topic testing of hypothesis. Over to you, sir. Thank you.
Okay, thank you, sir. Thank you very much. श्री छत्रपती शिक्षण संस्थाज राजर्षी शाहू महाविद्यालय ऑटोनॉमस लातूर डिपार्टमेंट ऑफ इंग्लिश ऑर्गेनाइजेस वेस्टर्न रीजन सेंटर मुंबई इंडियन काउंसिल ऑफ सोशल साइंस रिसर्च sponsored national level 12 days capacity building program on advanced research methodology for young aspirants in social sciences and humanities during 12th December to 23rd December 2022 through the online mode. I am very thankful to the principal of the college, Dr. Mahavidyalaya sir, Vice Principal Sadashiv Shinde sir, course coordinator Yadav sir, course director Dr. Anuja madam, course co-director and all members of the course. I am here I want to put one more thing is that I have worked for 6 years in Rajarshi Shahu Mahavidyalaya Latur and I know the entire society, Sri Chhatrapati Shikshan Samstha. I sincere express my thanks to the body members, Honorable Dr. Gopalji Patil, President, Secretary Dr. Anirudh Jadhav sir, and all members of the society who gave me opportunity as a guest lecturer for this session. Okay, thank you. I am going to deliver my lecture particularly on the hypothesis testing. It is my very favorite subject and majority of the research students are facing the problem how to set the hypothesis and how to test the hypothesis by using the various test measures by using the hypothesis testing. I mean whatever different measures are there, but I will focus only on one, that is the chi-square test. Okay. Firstly, before starting actually chi-square test, I am going to discuss firstly. Sir, is it readable the screen?
Sir, not sir. There is no slide. Please open it, the PDF.
Okay, okay. Is it now displaying the screen?
No,
Hello?
sir. No, sir, not visible, sir.
Not
Sir, not
visible?
displayed.
1 minute, one.
My computer, sir.
Yeah, yeah. One minute. Share from my computer, sir. Desktop.
Yes, sir. Now it is visible, sir.
Okay, okay. Thank you.
Yes.
Is it visible, sir?
Yes, sir. Yes.
Okay. 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 Hypothesis testing helps to decide on the basis of a sample data whether a hypothesis about the population is likely to be true or false. Statisticians have developed several tests of hypothesis, also known as the test of significance, for the purpose of testing of hypothesis, which can be classified as parametric test or standard test of hypothesis and non-parametric test or description-free test of hypothesis. Thus, particularly, hypothesis means nothing but hypothesis is the assumed statement before your research work. That your assumed statement may be false or may be true. That will prove after the whatever statistical measure we are using for testing that hypothesis. So, firstly, what are the types of hypothesis we are studying here? Firstly, parametric tests usually assume certain properties or parameters of the parent population from which we draw the samples. But non-parametric tests do not depend on any assumption about the parameters of the parent population. Non-parametric tests need more observations than parametric tests because they are not using any parameters of the population. That is, large sample size is required. Chi-square test was non-parametric test and applied for large sample. In this unit, we have to study the parametric test. Also, that is TTS and FTS. But here in this session, we are going to study only the chi-square test or non-parametric test. Hypothesis testing or errors. The first, when we apply the hypothesis testing and we find two types of errors, type 1 error and type 2 error. The first type of error occurs when null hypothesis is wrongly rejected, and the second type of error occurs when the null hypothesis is wrongly accepted. It means that it is shown in the table. Okay, the first column is null hypothesis when it is true, and second column when null hypothesis is false or not true. H0 means null hypothesis and H1 means alternative hypothesis. In rows, null hypothesis accepted is given and null hypothesis rejected is given. Now, see in the first cell, first row and first column, when null hypothesis is true and it is accepted, that is your correct decision. Second row, when null hypothesis is true but you are wrongly rejected, it means type 1 error. Okay, earlier already said type first error occurs when the null hypothesis is wrongly rejected. Means after having true your null hypothesis, we are going to reject. That type of error is called as type 1 error. Secondly, in second column, first row, When null hypothesis is wrong or false, and you are accepting, that is your type second error. And if your null hypothesis is not true or false one, and you are going to reject that one, it is your correct decision. Means while testing the hypothesis, these two types of errors may there, type 1 error and type 2 error. Type 1 error means when you are rejecting null hypothesis wrongly, and type second error means you are accepting the null hypothesis wrongly. Okay, we'll discuss later on regarding the null hypothesis and alternate hypothesis. Sampling errors are there. Okay, sampling errors are statistical errors that arise when a sample does not represent the whole population. They are difference between the real values of the population and the values derived by using samples from the population. Hello, am I audible?
Yes, sir.
Okay. This is just primary theoretical background is there. I am going to actually start the next one part. There are the difference between the real values of population and the values derived by using sample from the population. Since there is a fault in the data collection, the results obtained from the sampling become invalid. Furthermore, when a sample is selected randomly or the selection is based on bias, it fails to denote whole population and sampling errors will certainly occur. There are 4 types of sampling errors. Firstly, population specification error. It happens when the analysts do not understand who to survey. For example, for a survey of breakfast cereals, the population can be mother, children, or entire family. Number second, selection error. It occurs when the survey participation is self-selected by the respondents, implying only those who are interested respond. Selection error can be reduced by encouraging participation. Number 3, sample frame error. It occurs when a sample is selected from the wrong population data. Means whatever population data is there, if it is wrong, then automatically your sample will be wrong. And fourth one, non-response error. It occurs when a useful response is not obtained from the surveys. It may happen due to the inability to contact potential respondents or their refusal to respond. Okay, this is the primary part only. Means while testing the hypothesis, what type of errors may there, and while selecting the sample, what type of errors may there in general, where we have discussed here. Now we are going to study next one, actually chi-square test. Okay. The chi-square test is an important test among the several tests of significance developed by statisticians. Chi-square test symbolically written as like x square, but not it is the symbol of chi-square, pronounced as chi-square or chi-square, as a non-parametric test. The chi-square test is a non-parametric test. It can be used to determine if categorically data shows dependency or the two classifications are independent. Means this test is particularly used to know the dependency or to know the classification of two classifications are independent or dependent. Thus, the chi-square test is applicable in large number of problems. The test is in fact a technique through the use of which it is possible for all researchers to, number one, to test the goodness of fit, to test the significance of association between two attributes, and to test the homogeneity or the significance of population variance. Our chi-square test is a non-parametric test, and as a non-parametric test, it is a very important non-parametric test, and as so much, no rigid assumptions are necessary in respect of the type of population. म्हणजे या ठिकाणी in case of population we don't have any or we no need any having population parameters. We can apply directly chi-square test without any parameters. We acquire only the degrees of freedom, implicitly of course the size of the sample for use of this test. Means we need only the degrees of freedom, means it is based on the sample size. As a non-parametric test, chi-square test can be used as a test of goodness of fit and as a test of independence. Means for these two reasons, chi-square test as a non-parametric test is used. While using this test in case of as a goodness as a test of goodness of fit and as a test of independence, we no need of any population parameters. That's why this is considered as a non-parametric test. Chi-square test enables us to see how well does the assumed theoretical distribution such as binomial distribution, Poisson distribution or normal distribution fit to the observed data. When the some theoretical distribution is fitted to the given data, we are always interested in knowing as to how well this distribution fits with the observed data. The chi-square test can give the answer to this. Secondly, chi-square test as a test of goodness of fit. If the calculated value of chi-square is less than the table value at a certain level of significance for a specific degrees of freedom, the fit is considered to be a good one, which means that the divergence between the observed and expected frequency is attributable to fluctuations of sampling. But if the calculated value of chi-square is greater than its table value, the fit is not considered to be a good one. Chi-square test as a test of independence. Chi-square test enables us to explain whether or not two attributes are associated. Means particularly this test is commonly used for attribute testing. Means if two attributes are associated or not, for this chi-square test is mostly used. For instance, we may be interested in knowing whether a new machine is effective in controlling fever or not. In such situation, we proceed with the null hypothesis that the two attributes, namely new medicine and control of fever. Here two attributes are here, one side medicine is there and one side control of fever is there. And these two are independent, which means that a new medicine is not effective in controlling the fever. In case of chi-square test, one side, while putting the data, one side means whatever your data is there in rows and column is there. One side we are using the medicine, old medicine and new medicine, and for another side we are putting control of fever, control or not control, like one. And this 2 by 2 matrix we are putting this data, and whatever observed data is there, when we take the sample survey of 100, 200 or 500 respondents, whatever data is there observed there, we are putting one, and that will be compared with the expected event, and we are able to decide these two attributes are independent or not, or new medicine is effective or not on controlling the fever. Okay, actually we'll take the examples, no, don't worry about that. Chi-square test as a test of independence again. If the calculated value of chi-square is less than the table value at a certain level of significance for given degrees of freedom, we conclude that null hypothesis stands, which means that the two attributes are independent or not associated, or the new medicine is not effective in controlling the fever. Means when we are using the whatever observed data is there, whatever expected frequencies will be there, when we calculate the chi-square value, and if that calculated chi-square value is less than the table value, of chi-square, then it is said that these two attributes are independent, or these two attributes are not associated, or a particular new medicine is not effective in controlling the fever. But if the calculated value of chi-square is greater than its table value, our inference then would be that null hypothesis does not hold good, which means the two attributes are associated. That is, the new medicine is effective in controlling the fever and as such may be prescribed. Okay, one more thing is here that while applying chi-square test, whatever calculated value is there, that will be compared to the table value, and on the basis of that, if the calculated value is less than the table value, it means that null hypothesis is accepted, and if the calculated value is greater than the table value, it is considered as null hypothesis is rejected and alternative hypothesis is accepted. Okay, again we discuss about what is null hypothesis and what is alternative hypothesis in detail. Okay, parallelly. Next, conditions for applying chi-square test. Number one, observations recorded and used are collected on a random basis. Means while applying chi-square test, whatever data you are going to collect, that whatever observations you are going to collect, that should be based on the random basis, not the on selected basis. Number two, all the items in the sample must be independent. Means whatever items are there, whatever number of observations are there in your data, these must be independent. Number three, no group should contain very few items, say less than 10. In case where the frequencies are less than 10, regrouping is done by the combining the frequencies of adjoining the group so that the new frequencies become greater than 10. Some statisticians take this number 5, but 10 is regarded as better by the most of the statisticians. Means our chi-square test is a non-parametric test. No parameters are required for applying this test, but it is applicable only for the large sample. And whatever your large sample size is there, in case of any frequency for any cell, or first cell, second cell, for any cell, if it is less than 10, we need to regroup. Regroup means what? Suppose we have four groups. Suppose HSC, up to SSC, HSC, UG, PG, regarding the education attribute. And in case of HSC, very few data is there below 10. We can merge HSC with the SSC, and instead of 4 group, we have to make it only 3. First one up to HSC, UG and PG for applying the test. Okay, means chi-square test is a test for the large sample, not for the small sample. And if the any frequency for any cell is below 10, we need to regroup and adjust it. Then the results will be there according to our expectation or not. Number 4, the overall number of items must also be reasonably large. It should normally be at least 50. However small the number of groups may be. Okay. In case of chi-square testing, whatever your sample data is there, that must be at least equal to 50. The sample size must be 50 or more than 50. The constraints must be linear. Whatever constraints will be there, they also must be linear. Constraints which involve linear equation in the cell frequencies of the contingency table. That is, equations containing no squares or higher powers of the frequencies are known as a linear constraint. Okay. Okay. Now we are going to actually start how to calculate the chi-square value. Okay. How to calculate the chi-square value? The formula is that chi-square is equal to, it is the sum of what? O minus E. That means observed data. Whatever data collected by you, whatever survey undertaken by you, whatever figures are there, they are called as O. And we need to calculate on the basis of observed data expected one, that is called as E. What is IJ? IJ stand for, it is nothing but it is the cell address. I stand for row and J for column. If your data is number of rows and number of columns, in such case IJ stands for, it is the cell address. Means whatever O value is there, whatever O observed value is there, in what cell. While deducting E, E also must be from that corresponding cell. Suppose observed value or frequency is from first row and first column, at the same time E or expected value also should be from first row and first column cell IJ. When you are going to deduct E from O, after that you have to take the square of it, and after that you have to divide by corresponding E, means Eij. Whatever value you got, then at the end you have to make the sum of all these values. Okay, firstly O minus E, then square, then divide by E. After that, whatever result you got, you have to take the sum. That sum is nothing but that is the value of your chi-square. It is also written as O minus E whole square divided by E, then sum of these all. Okay, where Oij means observed frequency of the cell in the ith row and jth column. Eij means expected frequency of the cell in the ith row and jth column. Okay. First of all, calculate the expected frequencies on the basis of given hypothesis or on the basis of null hypothesis. Okay. Whatever observed frequency is there, that is already given in the problem, or whatever your observed data is there, whatever your collected data is there, that is considered as O. Now we are expected to calculate the expected frequency or hypothetical frequency. Now here, how to calculate? It is very simple to calculate the expected frequency. Okay, this is the 2 by 2 matrix. Okay, but total of first row is R1, total of second row is R2, total of first row is C1, total of second row C2, sorry, second column C2, and the grand total is GT or grand total. Now E11 is expected frequency for first cell. First 11 means this is the cell of first row and first column. Now E12 means what? Expected frequency for the cell having in first row and in second column. दुसऱ्या कॉलम मध्ये येणारा आणि पहिल्या रो मध्ये असणारा 1 2 means 1, firstly whatever number is there, that is representing the row number, and secondly second value representing the column number. 1 1 means first row, first column. 1 2 means first row, second column. 2 1 means first, second row, first column. 2 2 means second row, second column. Okay. Now, how to calculate the sale for the value, expected value for 1 1, expected value for 1 2, expected value for 2 1 sale, and expected value for 2 2 sale. It is very simple to calculate the expected value. Okay, here E1, while calculating E1 1 1, row 1 total multiplied by column 1 total divided by grand total. म्हणजे हे E11 काढताना या रो ची टोटल त्या करस्पॉन्डिंग कॉलम ची टोटल डिवाइडेड बाय ग्रँड टोटल, then you will get the E11. When you are going to calculate E12, at that time row 1 total multiplied by column 2 total divided by grand total. Now when you are going to calculate E21 sale, second row, due to that row second total multiplied by column 1 total divided by grand total is equal to E21, and for last sale E22 stands for R2 into C2 divided by GT or grand total. For example, is given here E11 is equal to R1 into C1 divided by GT or grand total. For ET2 is equal to R2 into C2 divided by GT or grand total. Likewise, we are going to obtain the expected frequencies by using this formula. Now next step, obtain the difference between the observed and expected frequencies, means O minus E. Find out the squares of such differences and calculate O minus E whole square. Then divide the quantity O minus E whole square obtained as stated above by corresponding expected frequency, that is Eij, to get Oij minus Eij whole square divided by E. Means firstly take the O, secondly take the E. After subtraction you take the square, and after taking square you have to divide by E. Then whatever value you got, find the summation of these all values, what we call sum of O minus E whole square divided by E. This is the required chi-square value. The chi-square value obtained such should be compared with the relevant table value of chi-square, and then inference be drawn as written above. Means after the calculation of this chi-square value, we need to compare with the chi-square table value of chi-square and then decide whatever your inference is there. Important characteristics of this chi-square test. This test as a non-parametric test is based on the frequencies and not on the parameters like mean and standard deviation. म्हणजे ही टेस्ट नॉन पॅरामेट्रिक आहे, कुठल्याही पॅरामीटरवर लाईक मीन अँड स्टँडर्ड डेव्हिएशनवर आधारित नाही. नाउ सेकंडली, the test is used for testing the hypothesis and is not useful for estimation. Okay. Number 3, this test possesses the additive property as has already been explained. Number 4, this test can also be applied to a complex contingency table with several classes. As such, is a very useful test in research work. This test is an important non-parametric test as no rigid assumptions are necessary in regard to the type of population. No need of parameter values and relativity less mathematical details are involved. Thank you. Now we are going to start actually problems and solutions on the chi-square test. And while taking the problems, I will discuss clearly how to set the hypothesis and how to test practically in your day-to-day research also. Okay. Now be careful, okay? Till now I have discussed only the theoretical part. Now I am going to take the actual numerical problems and how to set the hypothesis and how to test the hypothesis in a practical life. Okay. This is the problem. Firstly, consider the problem. The table given below shows the data obtained during the outbreak of COVID-19. COVID-19 च्या काळात हा डेटा आपण obtain केलेला आहे. Test the effectiveness of vaccination in preventing the attack from COVID-19. आपण काय करतो या ठिकाणी व्हॉटेवर व्हॅक्सिनेशन झालेलं आहे त्याचा इफेक्टिव्हनेस टेस्ट करणार आहोत की ज्यामुळे कोविड-19 अटॅक प्रिव्हेंट होतो का नाही. टेस्ट युअर रिझल्ट फाइल with the help of the chi-square at 5% level of significance. Table value of chi-square at 5% level of significance is 3.84. Table value is always given in the problem, but we are not going to solve the problem in day-to-day life. We are going to set the hypothesis for our research work, and where we need to test by using the chi-square. This is the problem for your example in general. And in example, the students are given the table value of chi-square, likewise 3.84 at 5% level of significance. But as a researcher, we need to find table value automatically. Table value is nothing but when you want to know the table value of for any your chi-square test, you have to take into account two things. One is that your degree of freedom, and secondly, at what level of significance you are going to take your hypothesis. Here you are asked test your chi-square at 5% level of significance. Okay, but in practical life, when you actually collect your data for your research, and for your collected data, when you are applying the chi-square test, in such case, how to know the table value? It is very easy. Chi-square distribution is there, table is there in statistics, or when you go through the Google search and when you put table value of chi-square or chi-square distribution, you got the chi-square distribution. One side you got the degrees of freedom, and another side you find there at what level of significance. Means 5% means 0.05, 1% means 0.01. Likewise, you observe the values. Practically, you find there one side you observe their degrees of freedom, and second side you observe there the values, table value of chi-square at 5% level or 1% level accordingly. Okay, so what is the degrees of freedom? Degrees of freedom means nothing but if your data is rows and columns, means tabular form. In such case, rows, number of rows minus 1 into number of columns minus 1 is the value of degrees of freedom. Degrees of freedom here are two columns. Okay, here are only two columns. That is, whatever attribute is there, one side COVID-19 attack and one side vaccination. Regarding COVID-19 attack, attacked and not attacked, and in case of vaccination, vaccinated and not vaccinated. Attribute classification is there. In case of attributes, whatever data is there, that may be at least in two heads, presence of attribute or absence of attribute, or so many more options may there, just like attack, not attack, or in other case other groups may be there. So here, in case of 2 by 2 matrix, there are 2 rows and 2 columns. So in case of degrees of freedom, R minus 1 means 2 minus 1 means 1 multiplied by C minus 1. C means column. 2 columns are here. 2 minus 1 means 1. 1 into 1 is equal to 1. So degrees of freedom for 1 at 5% level of significance, the table value you observe there 3.84. You can always search through the Google search chi-square distribution, and in case of chi-square distribution for 1 degree of freedom at 5% level of significance, the table value you will find there 3.84. Okay, now we'll discuss about the table. There are in all total 2000 samples are there. Out of 2000 samples, 500 people were vaccinated and 1500 people were not vaccinated. Out of 2000 people, 216 were attacked by COVID-19 and 1784 not attacked by COVID-19. Okay, and then 31 people are attacked by COVID-19 after having vaccinated. 185 people attacked by COVID-19 where those are not vaccinated. Then out of 1784 people, 469 were vaccinated and they are also not attacked by COVID-19. 1315 people were not vaccinated and they are also not attacked by COVID-19 attack. This is the data. Whatever figures are here, these are called as observed frequency O. Okay, while calculating chi-square value, we need to calculate the expected value. Now solution. In case of solution, firstly, in case of hypothesis testing, first of all, you have to set the hypothesis. Okay. The null hypothesis is that, let us take the null hypothesis means H0, that vaccination is not effective in preventing the attack from COVID-19. That is, the vaccination and attack are independent. Null hypothesis means what? Whatever two attributes are there, these two attributes we need to consider they are independent. They are not related. They are not associated, or one thing is not effective on another, or not one is not depending on another. It is considered as null hypothesis. Here, vaccination is not effective in preventing the COVID-19 attack. It means that the COVID-19 attack and vaccination, these two are independent. They are not dependent on each other. We assume initially. That is called as null hypothesis. सोप्या भाषेत सांगायचं म्हणजे नल हायपोथेसिस म्हणजे ज्या दोन ऍट्रिब्यूट मध्ये तुम्ही टेस्ट करता असोसिएशन बद्दल, ते दोन ऍट्रिब्यूट स्वतंत्र आहेत, त्यांचा एकमेकाशी संबंध नाही. These two are independent. These two are not associated. These two are not related. It is called as null hypothesis. Null means not negative. Null means neutral, unbiased. Means before your research work, when we are assuming one statement, that is called as hypothesis, and that assumed statement must be bias free, and in order to that we always put our hypothesis, null hypothesis. It is an impartial, it is an unbiased statement or assumed statement from the researcher side. That's why null hypothesis means whatever two attributes we are going to test, the whatever dependency or independency or whatever association in between these two attributes, you always assume these two are independent, or these two are not related, or these two are not associated. Here, vaccination and COVID-19 attack, these two are considered independent. It means that vaccination is not effective in preventing the attack from COVID-19. That is, vaccination and attack from COVID-19, these two are independent. This is the assumed statement before your research work. And after you are collecting data and applying chi-square test, your whatever assumed statement is there, they may be false or true, because this is the statement made by the researcher before your actual research work. Now apply the chi-square test. Chi-square test or chi-square is equal to, we know already, O minus E whole square divided by E. O मधून E वजा करा, त्याचा वर्ग करा आणि त्याला E ने डिवाइड करा. After that you take the sum of all. That is nothing but the chi-square value. Okay. O means already data given in the problem. Okay. O means already data given in the problem. That is the out of 2000 people, 500 were vaccinated and 1500 were not vaccinated. Out of 2000 people, 216 were attacked from COVID-19 and 1784 not attacked from COVID-19. Okay. Then corresponding each cell, whatever our 2 by 2 matrix is there, 2 rows are here and 2 columns are here. Whatever total data is there, that is classified in 2 groups according to attacked and not attacked, and according to vaccination, vaccinated and not vaccinated. Okay. This is observed frequency. We no need to calculate observed frequencies. Now go for second, expected frequencies. These we are required to calculate, not given. Okay, wrongly written here, given, not given, calculated. Now how to calculate the expected frequencies? Suppose here A stand for, okay, means for first cell. हा फर्स्ट सेल तुम्हाला काढायचा असेल, फॉर फर्स्ट सेल यू टेक इन टू अकाउंट द total of the first row multiplied by first total of the first column, means 500 into 216 divided by 2000, you will get the 54. Suppose here EAB, E means expected frequency, A stand for total of A, B stand for total of B, means row total and column total. 216 into 500 is equal to 54. Means in case of any value, in case of any cell, you can calculate the expected value corresponding row total into corresponding column total divided by grand total, you will get 54. For second cell, 500 multiplied by 1784 divided by 2000, you will get 446. Okay. In case of 2 by 2 matrix, it is also very easy to find without formula. When you got 54 value, in such case 216 minus 54, you will got 164. 2. Out of 500, if 54 value is there, then automatically will got 446. Likewise, we can find the values for each cell. Already I have given here how to calculate by using formula. Means if you want to find for AB cell, so A total into B total divided by grand total. For A small b, capital A total into small b total divided by grand total, you will get the value for each cell, that is called as expected frequencies. Okay. Okay. Then after O and E, next one is that calculation of chi-square value. How to calculate? First of all, put the observed frequencies. तुम्ही जे ऑलरेडी पहिल्या टेबलमध्ये होते फिगर्स ते जसे लिहिले. कसे लिहिले आपण? 31, 185, 469 and 1335. In second column, take the values expected frequencies. For first cell 54, for second cell 162, for third cell 446 and for fourth cell 1338. Now take the deduction O minus E. O means first column, E means second column, and O minus E means O minus E means 31 minus 54 is equal to minus 23. 185 minus 162 is equal to plus 23. 469 minus 446 is equal to plus 23. 1335 minus 1338 is equal to minus 23. Here wrongly written. 1 minute. I will adjust here. 1315 is figure is there. Okay. 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 1315 minus 1338 is equal to minus 23. Now after O minus E, you take the square. So minus 23 into minus 23 is equal to 529. Again 23 square means 529. Again 23 square means 529. And again minus 23 square means 529. Okay. Now next step, O minus E whole square divided by E. E means this one. Divided by 54. Divided by 162. Divided by 446. And divided by 1338. Now you got the values. O minus E whole square divided by E is equal to values are here 9.796, 3.265, 1.186 and 0.395. Total 14648.2. This is nothing but the value of chi-square as per our formula O minus E whole square divided by E. After that, when you take the sum of these all four values, then you will got what? The value of chi-square. Now, the chi-square value calculated 14.642 for the degrees of freedom. In this case, how to compute the degrees of freedom? R minus 1 into C minus 1. R stands for rows, C stands for columns. There are 2 rows and 2 columns. Minus 1 is equal to 1. So here degrees of freedom is 1. At 5% level of significance, chi-square table value is 3.84. You can observe in chi-square distribution through the Google search. The calculated value of chi-square just calculated 14.642 is greater than the table value of chi-square. Chi-square table value is 3.84. Hence, the null hypothesis, whatever put at the beginning by us, that is rejected. It means that the vaccination is effective in preventing the COVID-19 attack from. Okay. म्हणजे या ठिकाणी काय झालेलं आहे की कॅल्क्युलेट केलेली व्हॅल्यू ही 14.64 आली आणि टेबल व्हॅल्यू ही 3.84 होती. म्हणजे कॅल्क्युलेटेड व्हॅल्यू इज ग्रेटर दॅन 1, सॉरी ग्रेटर दॅन टेबल व्हॅल्यू. हेन्स आवर व्हॉट एव्हर नल हायपोथेसिस इज देअर दॅट विल बी रिजेक्टेड. आपलं नल हायपोथेसिस काय झालं? रिजेक्ट झालं. रिजेक्ट झालं म्हणजे काय झालं? It means that the vaccination is effective in preventing the attack from COVID-19. आपण ॲज्युम केलं होतं हायपोथेसिस मध्ये व्हॅक्सिनेशन इज नॉट इफेक्टिव्ह इन प्रिव्हेंटिंग द अटॅक फ्रॉम कोविड-19 आणि ते ॲज्युम केलं रिजेक्ट झालं. म्हणजेच अर्थ काय झाला? इट मीन्स दॅट द व्हॅक्सिनेशन इज डेफिनेटली इफेक्टिव्ह इन प्रिव्हेंटिंग द अटॅक फ्रॉम COVID-19. Likewise. Now we'll go for second problem. Okay. Okay. 1,000 students at college level were graded according to their intelligent quotient IQ and economic condition of their family. Use chi-square test to find out whether there is any association between their intelligent quotient and economic condition of their family. Given this is the symbol of degrees of freedom. Degrees of freedom is again here 1 because 2 rows are here and 2 columns are here. 2 minus 1 into 2 minus 1 is equal to 1, and at 5% level of significance again the table value is same because degrees of freedom is same and level of significance 5% is same. That's why table value is again same 3.84. Now consider table. 1,000 students of college level were graded according to firstly IQ and according to their economic condition of their family. त्यांच्या घराची स्थिती आणि त्यांचं IQ बुद्ध्यांक यावर आधारित क्लासिफिकेशन केलं. सो आउट ऑफ 1,000 स्टुडंट्स 600 स्टुडंट्स वेर फ्रॉम rich family and 400 students were from poor family. Again, out of 1,000 students, 700 students have high IQ and 300 students have low IQ. Now we are going to test here. What? Is there any association between the IQ and economic condition of the students' family? Means IQ of the students and economic condition of the family of the students. Is there any association? Is there any relation? We are going to test through the chi-square test. So this is the problem. Now by using this whatever observed data, we have to calculate expected frequencies and then we are calculate chi-square value and compare this chi-square value with the table value and decide our null hypothesis, whatever we are going to put, that is accepted or rejected. Okay, now solution. Okay, solution. Let us take the null hypothesis that first of all, while testing the hypothesis, first of all you put the hypothesis, you set the hypothesis, and let us take the null hypothesis that there is no any association or there is no any relationship between students' intelligent quotient and economic condition of their family. विद्यार्थ्यांचा बुद्ध्यांक आणि विद्यार्थ्यांची कुटुंबाची आर्थिक परिस्थिती यामध्ये काही संबंध नाही. It is considered as null hypothesis. Means the intelligent quotient and economic condition of the family, these two are independent and these two are not associated or these two are not related. It is considered as null hypothesis first. And now apply the chi-square test. Chi-square value is equal to whatever observed frequency is there, you have to deduct expected from that observed one and take the square, divide by expected frequency of that corresponding cell, and whatever values you got, you take the sum of these all values. That summation is called as chi-square value. So again, observed frequencies. Observed frequencies means already whatever frequencies are given in the table. They are out of 1000 students, 600 are rich family, 400 from weak or poor family. Out of 1000 students, 700 are having high IQ and 300 have low IQ. And out of 700, 460 from rich and 240 from poor. Out of 300, 140 from rich and 160 from poor. Now you are asked, is there any association between the IQ and economic condition of the family of the student? We are going to test by using the chi-square test. These are the observed data already given in the table. Now expected. We are going to find expected frequencies. While calculating 420, you take into account the total of row 1 600. Total of the first row means 600 multiplied by total of the column 700 divided by grand total 1000, then you will get the 420. बघा या ठिकाणी 420, 700 means column total into 600 means row total divided by 1000 means grand total is equal to 420. In case of second बघा यातलं how to calculate 180. 600 row total multiplied by 300 column total divided by grand total, then you will get the 180. Next, for second row first column, firstly take the row total 400 into column total 700, then you will get the divided by 1000, then you will get the 280 as expected frequency. Then out of 400 you deduct 280, then you will get the 120 by default. Okay, means missing frequency तुम्ही deduct करून सुद्धा काढू शकता. It is very easy to calculate. Okay, now calculation of the actual chi-square value. Firstly, put the O values, means the values from the observed frequency table. Then put the values from the expected frequency table. Then take the difference O minus E. 460 minus 420 is equal to 40. 140 minus 180 is equal to 40 minus 140. 240 minus 280 is equal to minus 40. 160 minus 120 is equal to 40. Now take the square of O minus E. Square of O minus E is equal to 4t into 40 is equal to 1600. Minus 40 into minus 40 is equal to 1600. Minus 40 into minus 40 is equal to 1600. Likewise, these are the squares. Then squares divided by corresponding E. Firstly, divided by 420. Secondly, divided by 180. Thirdly, divided by 280. And fourthly, divided by 120. Then you got the values 3.8, 8.8, 5.7, 13.33. The sum of these all is called as chi-square value, sum of Oj minus Eij whole square divided by Eij is equal to 1.7459. Okay. For the degrees of freedom, in this case, R minus 1 means rows minus 1 into C minus 1 means column minus 1 is equal to 2 minus 1 into 2 minus 1 is equal to 1. The table value of chi-square for 1 degree of freedom at 5% level of significance is already given 3.841. Now compare the calculated value of chi-square with the table value and then decide your hypothesis is accepted or rejected. The calculated value of chi-square 31.7459 is greater than the table value of chi-square 3.841. Hence, the above null hypothesis is rejected. It means that there is an association between students' intelligent quotient and economic condition of their family. या ठिकाणी सुद्धा तुमची व्हॅल्यू कशी आली, जास्त आली, आणि जास्त व्हॅल्यू आल्यामुळे तुमचं नल हायपोथेसिस काय होते, रिजेक्ट होते. कमी आल्यानं ऍक्सेप्ट होते आणि जास्त आल्यानं काय होते, रिजेक्ट होते. सो हिअर
Sir,
युअर
sorry,
नल
sir.
बोला
Patange, sir.
बोला.
Anuja
हा.
here, sir. It's a kind
Yeah.
request to you because our participants are, most of the participants are from South India and outside
Okay,
the
okay,
India. So
okay,
please, yeah,
okay,
continue in
okay, okay.
English.
Okay, I will try excuse in English. Okay, no madam. Okay. Due to having technical part, I am
Thank
using
you,
just
sir.
bilingual. Okay, madam. Okay, okay.
Thank
No,
you,
don't
sir.
worry.
Thank you.
Okay, well. Here, the calculated value is greater than the table value. That's why your null hypothesis is rejected. Null hypothesis rejected means what? There is an association between students' IQ and economic condition of their family. Okay. Now I will take the another example. Okay. Any doubts or any confusion is there if on the basis of whatever matter taught by me or discussed by me, you can ask afterwards. I will continue. Okay. I am not going to conclude my lecture, but till now, any doubts are there, I will discuss first. Okay. Hello. Anybody have any doubts? Ask me, please.
Sir, good evening, sir.
Good evening.
Sir, very interesting topic, sir. But not understanding,
Yeah.
sir. What is null hypothesis? I don't know idea, sir. That's why I call, sir.
Okay. I will discuss or I will explain clearly. Don't worry about that. And any doubt? Another anyone?
No,
Please?
sir. The calculation part, sir. T-test, the
No,
evaluation.
Definitely, I will explain the null hypothesis. Don't worry. Okay.
Yes,
Anybody
sir.
always please.
Hypothesis. Yes, sir. Thank
I
you,
will
sir.
explain detail. Oh, don't worry. Okay. Anybody any doubt, please? Okay. Anybody other, please? Okay. Sir, null hypothesis means nothing but I mean whatever attributes are there where we are going to test their association between two attributes before going your research work. We don't assume these two attributes are associated. These two attributes are correlated. We assume always that these two are not associated. These two are not related, or these two are independent. This is the unbiased. Null hypothesis means your assumption which is unbiased, impartial. When before your research work, before your study, when you assume these two things are associated, or these two attributes are associated, or these two are depend on each another, it is a biased statement. That's why researcher always put first of all null hypothesis. Null hypothesis means neutral. Whatever attributes you are going to study, whatever relationship we are going to study here, these two attributes we assume there initially they are independent, they are not associated, or if one side it is medicine and one side it is a treatment, or whatever your result is there, we assume there these two are independent, or this particular medicine, this particular treatment, this particular diet is not effective, not related, we assume that is called as null hypothesis. And alternative hypothesis we can put there. Alternative hypothesis means these two attributes are assuming that these two are associated, these two are related, these two are depending on each other. That is considered as alternative hypothesis. That is considered as H1. H0 means null hypothesis and H1 means alternative hypothesis. Here we are always set the null hypothesis, and in case of null hypothesis, the calculated value of chi-square is greater than the table value. It means that your null hypothesis is rejected. And if your calculated value is less than the table value, it means that your null hypothesis is accepted. But in these two examples, your calculated value of chi-square is always greater than the table value. That's why in both cases, your null hypothesis is rejected. Null hypothesis rejected means whatever two attributes are there, whatever two things are there, these two are associated, these two are related, or whatever medicine is there, that whatever vaccination is there, that is definitely effective on the whatever treatment is there, whatever disease is there accordingly. Okay, sir. Any more, please? Hello. Any more doubts, please?
Sir, thank you, sir. Thank you very much, sir. Understood, sir.
Okay, I will explain some more examples. Don't worry. Okay. I
Yes,
want
sir.
to clear complete this idea how to set the hypothesis for our research and how to test them and how to conclude our results. Okay. I will take another examples. Okay.
Yes, sir. Understood,
Anybody
sir.
doubt,
Understood.
Okay.
Not comparison. Yes, sir.
Yeah. Okay. I will share another. Okay. Problem number 3. Okay. Sir, this one is problem number 3. You are asked here, from the following data, find out whether there is any relationship between the sex or gender and preference of color. Okay. In column, gender is given, sex is given, males and females. And in rows, preference of color means how many are preferring red color, how many preferring white color, and how many preferring for green color. 200 people are there which have taken for survey. Out of 200 people, 50 are preferring red color, 100 are preferring white color, and 50 are preferring green color. Again, out of 200 people, 110 are male and 90 are females. Okay, this is the data observed or collected by the researcher, we assume here. Now you are asked to test what? Whether the two attributes, one side is sex or gender and one side is a preference of color. These two are associated or have any relationship. You are asked here. Here the null hypothesis will be, what will be there? There is no any relationship between the sex and preference of color. Means whatever gender is there and whatever preference of color is there, these two are independent. These two are not correlated. These two are not associated. We assume firstly, that is called as null hypothesis here. And here table is 3 by 2. Number of rows are here 3 and number of columns are here 2. So degrees of freedom is here 2. Degrees of freedom means what? Rows minus 1 into columns minus 1. Number of rows 3 minus 1 is equal to 2 and number of columns 2 minus 1 is equal to 1. 2 1 1 is equal to 2. Degrees of freedom is 2 and level of significance again same 5%. So table value is changed 5.99 because degrees of freedom is changed. And always degrees of freedom means what? Row minus 1 into column minus 1. If the data is not in row and column form, in only one row or in only one column, in such case, degrees of freedom means n minus 1. Whatever total values are there, from that you have to deduct 1, then that whatever value is there, that is called as degrees of freedom. But here the information or data is in rows and columns, that's why degrees of freedom is number of rows minus 1 into number of columns minus 1 is equal to degrees of freedom here 2. Table value is for 5% level of significance is 5.99. Again, one thing is that here 0.05 means 5% level of significance. It means that what? After applying chi-square test, your result probably may be correct 95% and may be wrong 5%. It is called as level of significance. Level of significance means 5% your result of the application of chi-square will be wrong and 95% will be correct or right one. That's why it means that 5% significance level, it means 95% confidence level. 95% confidence level means 5% level of significance. Okay. Now we are going to calculate actual the chi-square. Again the null hypothesis here. Let us take the null hypothesis that H0. H0 means null hypothesis and H1 means alternative hypothesis. That there is no any relationship between the sex and preference of color. Means male female असण्याचा means having male or female or having the preference of red, white and green. Is there no any connection? Is there no any relation? There is no any association that is considered as null hypothesis. Applying chi-square test, again formula is that what? O minus E whole square divided by E. Okay. Now O means observed data already given in the table O divided. Now we are required to calculate expected data. Okay. Again take into account here 10, 40, 70, 30, 30 and 20. These 6 values already given in the problem. This is the observed data, observed frequency given. Now you want to calculate expected frequencies that is required to be calculated. How to calculate? For first cell, 1 for first cell, total of the first row into total of the first column multiplied by grand total, you will get the 27.5. Then for second cell, this one 2 total of the second row into total of the first column multiplied by grand total, you will get the 55. For third one, total of the third row multiplied by total of the first column divided by grand total, you will get the 27.5. Okay. Then for second column, first row of the first column, first total of the first row multiplied by the total of the second column divided by grand total, you will get the 22.5. Then 100 multiplied by 90 into 100 multiplied by 90 divided by 200, you will get the 45. Again 50 into 90 divided by 200, you will get the 22.5. Means by using this formula we can calculate the expected frequencies. In simple, I will say again, for any cell when you are going to calculate expected frequency, you take into account the total of the corresponding row into the total of the corresponding column divided by the grand total. You will get expected frequency for any cell. You take into account the total of that corresponding row into the corresponding column total divided by grand total. You will get all these 6 values or expected frequencies. After getting expected frequencies, here formulas are given and calculation is also given. Next, after expected frequencies, you have to calculate directly the chi-square value. How to calculate? Firstly, put the O. O means observed values. Observed values. O. 10, 40, 70, 30, 30, 20. You can put one by one, row wise or column wise. Suppose here in this example, 10, 40, 70, 30, 30, 20 means firstly taken first row, secondly taken second row, thirdly taken third row. Similarly, while putting expected frequency, you put row wise. Firstly put first row, then second row, and thirdly third row. Likewise, O minus E, you will get now 10 minus 27.5 is equal to minus 17.5. 40 minus 22.5 is equal to 17.5. 70 minus 55 is equal to 15. 30 minus 45 is equal to minus 15. 30 minus 27.5, 2.5. 20 minus 22.5 is equal to minus 2.5. Now take the square, O minus E whole square. 306.25, 306.25. The square of 15 to 25, the square of minus 15 to 25, square of 225 is equal to 6.25, and square of the minus 2.5 is equal to 6.25. In case of square, minus minus will be plus. Okay. Now this square you should divide by corresponding E. So 306.25 divided by 27. Here divided by 22.5, here divided by 55, here divided by 45, here divided by 27.5, and here divided by 22.5. Means while calculating chi-square value, you put O clearly, secondly you put E clearly, then you take the subtraction clearly, then you take the square clearly, then divide by E clearly. Then whatever values you got whatever values are there, you take at the end sum. So formula is of chi-square is sum of O minus E whole square divided by E, means the sum of the last column, which is 34.35. Now compare with the table value. So firstly, chi-square value just calculated 34.35. For the degrees of freedom, in this case, row minus 1 into C minus column minus 1 is equal to 3 rows minus 1, 2 columns minus 1 is equal to 2. The table value of chi-square for 2 degrees of freedom, current degrees of freedom is here 2. For 2 degrees of freedom at 5% level of significance is 5.99. Now compare this table value with the calculated value and decide our null hypothesis is accepted or rejected. The calculated value of chi-square just now calculated 34.45 is greater than the table value of chi-square 5.99. Hence, the above null hypothesis is rejected because the calculated value is greater than the table value. That's why our whatever null hypothesis said by us, that is rejected. It means that there is relationship between sex and preference of color. Okay, at initial stage we said there is no any relationship between sex and preference of color, but now our whatever hypothesis was, it means that definitely there is a relationship between the sex and preference of color, and no more. Thank you. Okay. Okay, we take one more example again. Okay. Problem number 4. Use chi-square test and find out whether there is any association between employment and education of the people in a city from the following data. Given degrees of freedom is 1 because 2 by 2 table is here. 2 minus 1 into 2 minus 1 is equal to 1. So degree of freedom is 1. And level of significance is 5% again. That's why your table value is again 3.84. So data is what? 100 people are there. Out of 100 people, 60 are educated and 40 are uneducated. Out of 100, 70 are employed and 30 are unemployed. Here you need what? Whether there is any association between the employment and education, means employment and education, these two things are associated or not. We firstly assume these two are not associated, or there is no any association between employment and education. It means that null hypothesis. And this null hypothesis we can test by using the chi-square test likewise. Okay, firstly, let us take the null hypothesis that there is no any association between employment and education of the people in a city. This is the null hypothesis. First of all, we set the hypothesis. Then after, apply the chi-square, and lastly, conclusion or finding the result. Firstly, chi-square test or value is equal to, again, O minus E whole square divided by E. Then sum of these all is called as chi-square value. Observed frequencies, whatever given in the table, these again put as observed frequencies. Then calculate the expected frequencies, and expected frequencies are, first one 42. How? 60 into 70 divided by 100 is equal to 42. Then 60 into 30 divided by 100 is equal to 18. Then 40 into 70 divided by 100 is equal to 28. Then 40 into 30 divided by 100 is equal to 12. Or we can take directly 60 minus 42 is equal to 18. 70 minus 42, it will come 28. 30 minus 18 is equal to automatically 12. You can calculate by using this also remaining or missing figure. By using the formula, for first cell, row 1 total into column 1 total divided by grand total for the first cell expected value. Likewise, corresponding row total and corresponding column total, you take into multiplication and divide by grand total, then you will get the expected frequencies. Now calculation of the chi-square value. Firstly O, secondly E, okay, thirdly O minus E, then square, O minus E square, and then divide by E. So 46 minus 42 is equal to 4, 14 minus 18 is equal to minus 4, 24 minus 28 is equal to minus 4, and 16 minus 4, 12 is equal to 4. 4 square 16, minus 4 square 16, minus 4 square 16, and 4 square 16. Divided by E, O minus E whole square divided by E. E means divided by 42, 16 by 42, 16 by 18, 16 by 28, 16 by 12. Then you will get the values like what? 0.38, 0.88, 0.57, 1.33. The sum of these all values is 3.174. Now compare. For the degrees of freedom 1, the table value of chi-square again 3.84. Now the calculated value is 3.174 is less than the table value of chi-square 3.84. Here calculated value is less than the table value. Hence the above null hypothesis is accepted. Hence the above null hypothesis is rejected. Hence, here above null hypothesis is accepted. It means that there is no any association between employment and education of the people in a city. Okay. आतापर्यंतच्या whatever hypothesis, whatever examples we have taken now, out of 4 examples, this is the first example where the calculated value is less than, the less than the table value. Hence here our null hypothesis is accepted, means whatever assumed in our null hypothesis, that is proved or true. So it means that there is no any association between employment and education of the people in a city. Any doubt, please ask me. Hello? Any confusion,
Hello,
any
sir.
doubt, please ask me.
Hello, sir. Hello, am I audible?
Yeah.
Sir, we have special doubt session after the session, sir.
Okay. Okay, I will continue another problem. Okay.
Yes.
Are you
Yes.
ready?
Yes.
Okay, thank you. Okay. You are given a sample of 150 observations classified by two attributes A and B as follows. Use chi-square test to examine whether A and B are associated. The table value of chi-square for 4 degrees of freedom at 5% level of significance is 9.49. Here degrees of freedom is 4. Level of significance is same. And due to that table value is changed 9.49. Why? Because here there are two attributes A and B. A has three groups A1, A2, A3. B also has three groups B1, B2, B3. Like suppose in case of workers, skilled workers, semi-skilled workers, unskilled workers. In case of here male, female or any other. Likewise, groups may be 3 or more, 2 or more, maybe 3 or 4. No doubt. Don't worry about that. Here are 3 by 3 table is there. So number of rows are 3, number of columns are 3. So row minus 1 means 3 minus 1 into column minus 1 means 3 minus 1 is equal to 2 into 2. 2 into 2 is equal to 4. So degrees of freedom is here in this case 4. And for 4 degrees of freedom at 5% level of significance, the table value of chi-square is 9.49. And you are asked the attribute A and attribute B are associated or not. So first we take into account our hypothesis, that is the null hypothesis, that let us take the null hypothesis that there is no any association between two attributes A and B. Applying chi-square test is equal to O minus E whole square upon E. Now take the sum of these all is called as chi-square value. Firstly, observed data already given in the table. Okay. Now calculate the expected frequencies for each cell. So for first cell, 80 into 60 divided by 150 is equal to 32. Again 80 into 60 divided by 150 is equal to again 32. Here 60, again here 60 for second column also. That's why for first column and second column your values are same, 32, 32, because 60, 60 are here. Then for third cell, 80 into 30 divided by 150 is equal to 16. Now go for second row. Second row, first column, 45 into 60 divided by 150 is equal to 18. Again same for second column, because the total of second column is remains same, 18, 60. Okay. Then for third column, 45 into 30 divided by 150 is equal to 9. Now last third row is there, remaining row is there. You can take directly also likewise 60 minus 32 plus 18 is equal to 10. 60 minus 32 minus 18 is equal to 10. 30 minus 16 and 9 is equal to 5. Or you can take directly by using our formula, row total 25, column total 65 multiplied by, okay, then divided by 150, then you will get 10. Again here 25 into 60 divided by 150 is equal to 10, and for last cell 25 into 30 divided by 150, you will get the 5. This is the expected frequencies calculated here. E11 first row first column, 12 first row second column, 13 first row third column. Take the multiplication and then divide by grand total. Then you will get the values for every cell of expected frequencies. Now calculation of the chi-square. First column observed frequencies, second column expected frequencies, third column O minus E, fourth column O minus E square, fifth column O minus E square divided by E. Then actual values are taken here, okay, and at the end you have to take the sum of O minus E whole square divided by E is equal to 10.9826. Now compare with the table value and then decide the hypothesis is accepted or rejected. Okay, for the degrees of freedom here, in this case R minus 1 into C minus 1 is equal to 3 minus 1 into 3 minus 1 is equal to 4. The table value of chi-square for 4 degrees of freedom at 5% level of significance is already given 9.49. The calculated value of the chi-square 10.98 is greater than the table value of chi-square 9.49. Hence the above null hypothesis is rejected. It means that there is association between two attributes A and D. Here null hypothesis is rejected. That's why these two attributes has association, or these two attributes are associated to each one. It is our inference or conclusion. Okay. In practical life, these are the examples which are generally asked in exam. In practical life, whatever your data collection is there, for your data collection, you have to set your hypothesis, and also you are able to test by using the chi-square. How to set the hypothesis? Okay, in your questionnaire, the first part is a demographic part, and second part is, whatever opinion survey is there, and we are very interested to test whether any relationship in between demographic factor with your responses. Suppose your responses are there on the basis of your responses are on the basis of, suppose here satisfaction survey is there, student satisfaction, customer satisfaction, whatever may be opinion is there, you are asking the question regarding the satisfaction of consumer or regarding the satisfaction of the students, and one side your demographic factor is there, that is suppose student age student age may there, student male female gender is there, student locality rural and urban is there. Again in case of people, the category of the people may there rural and urban, male female, educated uneducated, HSC UG PG likewise, then age group in between 10 to 20, 20 to 40, 40 and above. Likewise, you have so many classifications of your data according to your demographic factor. At the same time, you are asked the question regarding the satisfaction regarding a particular point to all your respondents, and they have responded likewise satisfied, not satisfied, they are in decision or not. Whatever your responses are there, they may be group at least in two classes, satisfied or unsatisfied, or in another more, semi-satisfied, little bit satisfied. Likewise, according to your aim, you can classify different groups, and whatever data is there that is in table, you can set the hypothesis that, for example, there is no any association between age group and satisfaction of the people. This is your hypothesis, null hypothesis. What is that? There is no association between the age group and satisfaction of the people. Second hypothesis will be there. There is no association between gender and satisfaction of the people. Again, one more hypothesis made there. There is no association between locality of these people and satisfaction. Likewise, so many hypotheses you can set for your own research and can apply practical life with your full confidence, and then you get the result accordingly and nothing else. If any doubts, you may ask, please. Okay. Any doubts, you can ask me. Okay. Am I audible, please?
Yes, sir. Yes, sir. Sir, you are audible, sir.
Yeah, thank you. Ask any confusion practically. I am very practical teacher and I am applying day-to-day research, whatever chi-square test is there. Not I am only teaching to the students in class for examination mark. Whatever your day-to-day research is there, and in case of research, how to apply the chi-square. And in case of, if your data is tabular form, degrees of freedom is row -1 into column -1. Okay. But in case of, if your data is in only one line, in only one column or in only one row, in such case, degrees of freedom means what? n-1. Number of values or observed data they are -1. n-1. And chi-square distribution already is there in the books of statistics, or through the Google search you find so many chi-square distribution tables, and there one side you observe their degrees of freedom and another side you observe their significance level. Like degrees of freedom is 1 and significance is level 5. So you go through the row and column corresponding cell and find their chi-square table value. Okay.
Good evening. Good evening, sir.
Good evening. Yes.
I'm Dr. Malega from Erode, Tamil Nadu. So I have one a doubt. We are framing a null hypothesis. There is no correlation or relationship between the variables. Normally, we are framing the null hypothesis. Is it?
Yeah.
Alternative hypothesis, there is a relationship between the variables. Is it any possibilities, sir? It is correct? And in null hypothesis, the relationship between the variable?
Ma'am, hello.
Sir, the frame hypothesis.
Okay. Yeah. One more thing is there. Your hypothesis, you put null hypothesis or alternative hypothesis. No need. It is not the concrete idea what hypothesis you should put there.
Okay.
But whatever your result is there, on the basis of your result, if your calculated value of chi-square is greater than the table value, your null hypothesis will be rejected.
Okay.
And your alternative hypothesis will be accepted. If you put alternative hypothesis directly without null hypothesis, when you set or you put your alternative hypothesis, then whatever your result is there, result will be same. If your null hypothesis is there, that will be rejected.
Okay.
But your alternative hypothesis is there. So in such case, your alternative hypothesis will be accepted. Okay.
Oh, okay, sir.
Only if your calculated value is greater than the table value, your null hypothesis will be rejected. If your alternative hypothesis is that, that will be accepted. Okay.
Oh,
Okay. You can put alternative
sir.
also, no doubt is there. And sometimes researchers may put both alternatives, H0 or H1. H0 means null hypothesis and H1 means alternative hypothesis. And on the basis of result, you can say at the end, the calculated value of chi-square is greater than the table value. Hence, the null hypothesis is rejected and alternative hypothesis will be accepted. Likewise, you can conclude there.
Okay, sir. Thank you, sir.
Okay, welcome, madam. Any other, please?
Participants are requested, please ask your doubts, questions, or queries regarding hypothesis. I think, sir, you explained the topic in such a manner that there is no any doubt, query regarding hypothesis and types and how to test it. Please, participants, please
ask anybody. Any confusion, any doubt? Okay, when you are going to undertake the research, day-to-day life, or for PhD, for MPhil, for any work, how to analyze the data by using, or how to interpret the data by applying testing of hypothesis, particularly chi-square test.
Hello. Hello.
yes, sir.
Hello.
Audible.
Yes, sir. Yes,
सर
sir.
मला सरांना विचारायचं की नल हायपोथेसिस संदर्भात थोडंसं सविस्तर तुमची माहिती द्या.
नल हायपोथेसिस म्हणजे काय बघा. हॅलो सर. नल हायपोथेसिस म्हणजे मूळ गृहीतक. मूळ गृहीतक म्हणजे काय, आपण रिसर्च करताना या दोन ऍट्रिब्यूट मध्ये, गुणधर्मामध्ये किंवा लक्षणामध्ये संबंध आहे असा अभ्यास करताय. आणि अभ्यास करतानाच आपण असं गृहीत धरणं कसं की ते दोन ऍट्रिब्यूट एकमेकाशी संबंधित आहेत किंवा एकमेकावर अवलंबून आहेत, असं गृहीत धरणं हे थोडं बायस वाटतं. म्हणून आपण काय करतो, ते दोन ऍट्रिब्यूट ज्याचा तुम्ही अभ्यास करताय त्या दोघांचा काही संबंध नाही, ते दोघं एकमेकाशी संबंधित नाहीत किंवा दे आर नॉट कोरिलेटेड किंवा दे आर नॉट असोसिएटेड किंवा एक घटक दुसऱ्यावर आधारित नाही किंवा नवीन ट्रीटमेंट ही त्या डिसीजवर परिणामकारक नाही असं गृहीत धरणं म्हणजे न्यूट्रल आहे. न्यूट्रल म्हणजे नल. नल म्हणजे निगेटिव्ह नाही. नल मीन्स न्यूट्रल.
नल म्हणजे निगेटिव्ह नाही.
Unbiased assumed statement is called as null hypothesis.
ओके.
घ्या तुम्ही आता ज्या दोन तुम्ही व्हेरिएबल घेता, व्हेरिएबल किंवा ऍट्रिब्यूट घेता या रो मध्ये एक आणि कॉलम मध्ये, त्या दोघांमध्ये
दोन
संबंध नाही.
सर दोन
सिंगल याच्यात तुम्ही घेता येते ना,
घेता येते ना.
लक्षात म्हणजे काय लक्षात येईल. सर ऐका सांगतो थोडं. हायपोथेसिस म्हणजे काय असतं माहिती का, तुम्ही जो ऑब्झर्व्ड डेटा आहे हा ऑब्झर्व्ड डेटा आणि एक्सपेक्टेड डेटा हा जवळपास सारखा आहे असं गृहीत धरणे म्हणजे नल हायपोथेसिस. ऑब्झर्व्ड डेटा म्हणजे काय गृहीत धरता, तुम्ही रो आणि कॉलम नाहीत, फक्त सिंगल रो आहे. सिंगल रो म्हणजे कसं लक्ष द्या सांगतो. तुम्ही तुमच्याकडे तुमचे 6 विषय आहेत आणि 6 विषयाची एक्झाम दिली आणि 6 विषयाची एक्झाम नंतर जे तुम्हाला मार्क्स मिळाले ते मार्क्स म्हणजे ऑब्झर्व्ड डेटा. बरोबर आहे. आणि ऑब्झर्व्ड डेटा काढल्यानंतर तुमचं सरासरी आला ऍव्हरेज ते आहे 60. ऍव्हरेज किती आहे 60. याचा अर्थ काय, प्रत्येक विषयात 60 असं गृहीत धरले तर तुमचे टोटलची ते मॅच होते. तर तुमचा ऑब्झर्व डेटा काय म्हणतो, एका विषयात 80 आहेत, एका विषयात 40 आहेत, एका विषयात 70 आहेत, एका विषयात 60 आहेत. हे ऑब्झर्व डेटा आहे, बरोबर आहे. परंतु एक्सपेक्टेड काय म्हणतो, एक्सपेक्टेड डेटा काय म्हणतो की प्रत्येक विषयात तुमचे असायला पाहिजे 60. कारण ऍव्हरेज तुमचं 60 आहे. ऍव्हरेज किती आहे? 60. प्रत्येक विषयात 60 असायला पाहिजे, पण तुमचे आहेत का 60? नाही. मग हे दोन्ही वेगळे आहेत. पण इनिशियली जेव्हा तुम्ही हायपोथेसिस पुट करता तेव्हा तसा काही फरक नाही असं म्हणणे, तसा काही फरक नाही असं म्हणणे म्हणजे नल हायपोथेसिस आहे. मग ओ डेटा म्हणजे तुमचे मिळालेले 6 विषयांचे मार्क, ई डेटा म्हणजे तुम्हाला एक्सपेक्टेड असलेला 60 डेटा, ओके, 60 डेटा असा आहे. ओ मायनस ई करताना आपलं 6 जे विषयाचे मार्क्स आहेत ते अगोदर तुमची ओरिजिनल घ्या, मायनस 60 करा प्रत्येकातनं, म्हणजे ओ मायनस ई आलं. त्याचा ई मायनसचा वर्ग करा, डिवायडेड बाय ई करा, तुमची त्याची सम करा, ती काय येईल? तुमची chi² व्हॅल्यू येईल. आता या केसमध्ये डिग्रीज ऑफ फ्रीडम म्हणजे काय घ्यायचं? फक्त एकच रो आहे, एकच रो आहे, कॉलम नाही. त्यामुळं या ठिकाणी n-1 किती आकडे आहे तुमचे? विषय 6 आहे. 6 विषयातनं 1 गेला म्हणजे 5 आले. डिग्रीज ऑफ फ्रीडम 5 मध्ये जा टेबलमध्ये, chi² डिस्ट्रीब्युशनच्या टेबलमध्ये डिग्रीज ऑफ फ्रीडम 5 मध्ये लेवल ऑफ सिग्निफिकन्स 5 असेल तर 5% त्याच्यामध्ये जा, ती टेबल व्हॅल्यू चेक करा. त्या टेबल व्हॅल्यूची तुम्ही काढलेली chi² व्हॅल्यू आय मीन कम्पेअर करा आणि ठरवा. काय ठरवा आता? आपलं गृहीत काय आहे की तुमचे जे विषयाचे मार्क आहेत सगळ्या विषयांचे ते बरोबर आहेत, असं काही नाही विषय बघून मार्क कमी जास्त मिळाले, बरोबर आहे. हिस्ट्रीमध्ये जास्त मिळाले आणि इंग्लिशमध्ये कमी मिळाले असं काही नाही, असं आपण ऍज्युम केलेलं आहे नल हायपोथेसिस. आणि तुम्ही आता कम्पेअर केल्यानं कळेल तुम्ही नल हायपोथेसिस जे ऍज्युम केलात ते रिजेक्ट होणार का ऍक्सेप्ट होणार, ते कॅल्क्युलेट केल्यानं कळेल सर.
ओके
किंवा तुम्ही असं पण घेऊन बघा, प्रत्येक 60 मार्क्स आहे
सर. थोडस नाही आपण महाराष्ट्रीयन आणि आपण इतर लोकांसाठी आपण इंग्लिशमध्ये आणि हिंदीमध्ये कम्युनिकेशन करून राहिलो. आता मी 5-6 दिवसात आपला आपण अदर स्टेटमध्ये जर जातो तर आपल्या विषयाची कोणी काळजीच नाही घेत आणि तिथे इंग्लिश आणि हिंदी, इंग्लिश आणि हिंदी हेच चालू होतात. आपल्या महाराष्ट्र सर ओरिएंटेशन
Please don't take the other issues in the session. This is purely the program sponsored by ICSSR on the national level. Please don't raise such type of the issues which may have some controversy. It's a kind appeal to you, sir. What, sir? Please.
नाही मॅडम, ते सगळं ठीक आहे. मी आता मी
अदर I don't want any arguments on this issue, sir. Please.
You have 2 options, either English or Hindi, sir. No option for Marathi. But sometimes whatever doubts are there, we are required to clear now. Okay.
Okay.
I'll try now.
ठीक, thank you.
Anybody want?
Yeah, Dr.
I think, sir, there are no doubts from the participants.
Okay, thank you.
Okay, thank you, sir. Thank you for informative and resourceful talk. And I hope that it has cleared most of the doubts about testing of hypothesis. Now, I am going to moving towards the last session of this session, that is oath of thanks. First of all, I would like to extend my heartfelt gratitude to our esteemed speaker, Dr. H.S. Patange sir, who accepted our request yesterday and made this wonderful session today. Thank you, sir. Thank you very much. My sincere thanks to our principal, Dr. Mahavidyalaya sir, for supporting and guiding us to conduct such program. Also, I am thankful our Vice Principal, Professor Yashvant sir, IPSC Coordinator and OSD, Dr. Abhijit Yadav sir. I am also thankful to our respected HOD, Dr. Anuja Jadhav ma'am, for giving me opportunity to conduct this session. I am very much thankful to my respected colleagues Dr. Sachin Bhandari sir, Dr. Chandrasekhar Doni sir, Dr. Sachin Kale sir, Dr. Nitin Bhalke sir, Mr. Deepak Thorat sir, Vaishali Guru madam for kind support and motivation. I also like to thank our technician Ankush Senige and Babu. Finally, I would like to thank you all the participants for being here and making this Sunday a wonderful and memorable one. With this, I declare that today's session is over. Thank you, one and all.
Thank
You
you
will
all.
get the feedback form and questionnaire. All participants are requested to fulfill them and submit. Thank you, sir. Patange, sir, thanks for your
Thank you,
resourceful
madam. Thank
session.
you, madam, and all.
Yes, sir. Yes,
Thank
yes.
you.
Thank you, sir. Thank you.
Thank you for giving me an opportunity.